Hello, everyone. So the research question that I decided to make my data over is which is more effective at lowering heart rate, running more often for shorter periods of time, or running less frequently for longer periods of time. So as you can see, I made two tables. One group, which has 10 subjects, runs 2 times a week for 20 minutes. The other group, which also has 10 subjects, runs 4 times a week for 10 minutes. So both groups are running the same amount of time overall per week. One group obviously just has more running sessions, if you will, than the other. So down here, I made my anticipated chart or line graph. These are the anticipated heart rate averages um, over an 8 week time period. So first off, as you can see, I anticipated that the 4 by 10 group will have the most dramatic of change in heart rate and therefore is more beneficial. Um, so an example of an observational study we could do that would test this is I could go to a public track, and before the runners or ask random runners there before they start running because we want their resting heart rate, if I could take their heart rate and then ask them how many times a week they run on average. So then that would help us determine if running more times a week is more beneficial than running for longer periods of time. I mean, this would be a really tough uh, way to way to conduct this study. Would be an observational one for a couple of different reasons. One big limitation this would have is we are relying completely on uh, the person's memory, if you will. So maybe they overestimate how often they run per week on average. We just don't know because we don't have that control that we would have with an experimental study. So basically, the big thing is there's less control there. With an experimental study, which is what I have graphed here and is on the screen, is you're able to have a lot more control. This group ran 2 times for 20 minutes. That we can control that. We can make that precise and exact. This group ran 4 times for 10 minutes. That's precise. That's exact. All these numbers here in the table are resting heart rates. We know that for sure. Um, so I mean that's a big positive or a big pro for experimental studies is you have much more control. A con is obviously be more expensive. More than likely, you'd have to pay the subjects or give them some sort of incentive for participating. Um, but yeah, so this experimental study, we'd want to make sure we have our control set, which we do. As I already mentioned, resting heart rate. We would control the minutes of running, speed times, or yeah, times per week, as I already mentioned. We would want to randomize the subjects, so pick random people. Um, Another piece of the control that I feel like I should mention that's important here is they would have to be all non-runners. They don't run consistently because obviously, if you get a runner who say runs 5 miles a day, their resting heart rate to begin with here at week zero will be much lower than someone who doesn't run. Therefore, they will have their heart rate will decrease less over the 8 week span. The third step of an experimental study is replicate. So we'd obviously want to be able to replicate our findings. And finally, for the fourth, the block, uh, we could compare different blocks of people in this study. So we could compare men and women. We could compare different age groups, all that uh, along that sort of line. So here's the chart I made. I made up all these numbers, of course. This is not based off an actual study, but based off the numbers I made up here, we can see that my original hypothesis is was not confirmed. Basically, the slopes of these two lines are fairly similar. Here, week 7, it kind of crosses over a little bit, but for the most part, uh, they run their slope is fairly close to each other. Therefore, we cannot confirm that uh, one of these groups benefits more than the other, if you will. So that's what I decided to do my research study on. Like I said, I made up all this data, and